Welcome to my channel, Machine Learning with Pats. Today I am introducing the upcoming series titled, Machine Learning for Mechanical Engineers. The topic of today's discussion is various approaches to ML, supervised, unsupervised and reinforcement learning. I am your instructor Abhishek. Today, we delve into the fascinating world of machine learning, exploring its different approaches and understanding how they impact our daily lives as engineers. Let me take you back to a moment in the not-so-distant future, where robots gathered for a chat over popcorn, discussing their unique struggles in the world of machine learning. Look at this picture where robots kick back and enjoy popcorn just like us. Well, today, we have Robot A, Robot B, and Robot C engaging in a lively discussion about their struggles in their robotic life cycle. Robot A, who represents supervised learning, starts the conversation at, "Hey, fellow robots, I've been through so much. They gave me tons of data to read and tests to take. It's like going through robot school all over again." Now Robot B, who represents unsupervised learning, adds, "Tell me about it, Robot A. But you know what's interesting? At least, in my case, they gave you the answers. I might not have a teacher, but I get to explore and figure things out on my own." And most interesting statement is by Robot C, who reinforcement learning, Robot says. You too, at least you don't make your own book. I learn by trial and error, navigating the complexities of the environment. It's a bit like writing my own story without a script. Interesting conversation, right? Let's understand supervised learning in detail. Look at the picture 1. Here input and output values are already known, and the machine learning algorithm learns by mapping input to the output. Mathematically, for y as the output and x as the input, machine learning algorithms try to find mapping function f such that y equals f, x. If you observe closely, learning happens like some supervisor supervises the learning process. We already know the answers, so the algorithm tries to map the function so that the predicted output must be close to the actual output. Do you remember Robot A's struggle with supervised learning? In supervised learning, the robot is given labeled data, that is answers, to learn from. It's akin to a structured learning environment with clear instructions. Let's say the machine has learned a mapping function f predicting values y for every x passed as an input to the function. Once the difference between predicted y and actual y goes below a certain threshold, in simple terms, errors become negligible, learning stops. Now look at picture 2, which shows how does classification be undertaken using supervised learning. Taking the example of this picture, various shape, that is raw data, along with their labels, that are outcome, are the input to the machine learning model to learn the association and recognize the shape names when tested on a new data sample. Based on these input and output, the model learns to classify the category of unseen image data, whether a rectangle, circle, triangle, or hexagon. Now please understand supervised learning in case of regression. Look at this picture. It shows experience in years on the x-axis. For every experience, there is one salary per month rupees on the y-axis. Green dots are the input and output data coordinates x and y. So regression problem tries to find the continuous mapping function from input to output variables, for example, the blue line in the image. If the order of the mapping function is fixed to 1, which is a linear function, the model will learn the blue line shown in the image. We will move towards unsupervised learning now. Look at picture 1. Here, we know the value of input data, but the output and mapping functions are both unknown. In such scenarios, machine learning algorithms map the function that finds similarity among different input data instances and groups them on the similarity index, the output for unsupervised learning. We can say that algorithms generate a pseudo-output for learning the mapping function. In such learning, there is no supervision as there is no existence of output data. Hence they are called unsupervised learning. Algorithms try to find similarity between different input data instances by themselves using a defined similarity index. Do you remember Robot B's experience in unsupervised learning? It involved exploring patterns without labeled data. Robot B's comment aligns with the idea of independent exploration and discovering hidden insights. Using the example in Picture 2, we have input data consisting of images of different shapes. Machine learning algorithms try to find the similarity among other images based on the color pixel values, size, and shapes and form the groups as outputs in which similar input instances lie. If squares get clustered together, and similarly, circles and hexagons. Now it is time for reinforcement learning. Here, machine learning algorithms act as virtual agents in the known environment where these agents choose the possible action options. The agent selects the best action from all the possibilities present in that environmental state and, based on that selection, receives reward/risks. The algorithms keep an eye on maximizing the reward, reducing the risk, and eventually learning. Let's take one example, so look at Picture 1. Suppose we want our computer to learn how to balance the pole on the moving cart. We might have played this game in childhood, balancing sticks on our palms. Here, the hand is replaced by a cart. Suppose we want to make our cart smart enough to balance the stick. So, cart is the agent, the plane on which the cart will move is the environment, and the cart is taking possible actions such as moving either left or right to balance the stick. So, whenever a stick falls in either direction, the cart will act appropriately to make it stand. Suppose we told our agent that the longer it holds the stick upright, the higher the reward will be. After every action, the state of the cart and the stick in the environment will change. Our agent will analyze that state and again different actions best suitable for that particular state. This can be understood by looking at Image 2. Do you remember the most tragic is Robot C's challenge in reinforcement learning that requires learning through interaction with the environment, facing uncertainties, and making decisions? Robot C's struggle represents the dynamic, trial and error nature of reinforcement learning. It is a quiz time. The questions are based on the session we undertaken. Instruction. Answer in comment box. If answer to question 1 is B, then write 1B. Questions are as follows. 1. What is the primary characteristic of unsupervised learning? A. The algorithm is trained on labeled data. B. There is a clear teacher or guide provided. C. The algorithm explores patterns without labeled data. D. The learning involves trial and error in a dynamic environment. 2. What is the key aspect of reinforcement learning? A. Learning from labeled data. B. Independent exploration. C. Predicting outcomes with certainty. D. Learning through interaction with the environment. 3. What does the term labeled data refer to in supervised learning? Data with hidden insights. B. Data without any patterns. C. Data paired with known outcomes. D. Data from unsupervised environments.